When we started the Pinterest integration for this Fortune 500 grocery retailer, their focus was on moving away from third-party data collection. They were already collecting server-side event data, so it only made sense to remove the client-side third-party mechanism in favor of controlling the data stream. This solution puts the customer in a position to handle how data is shared without giving up control to any third party. As a side benefit, it also means that fewer assets are loaded on every page, reducing total page load times and the number of potential security threats. Our testing process was fairly simple. After some initial development, testing, and validation, we deployed to one of the customer's lower volume sites, a popular chain in the Denver area. We set the server-side integration to run in parallel with the client-side integration that they had already deployed. This let us run tests and then directly compare the event volumes and match rates between both setups for the same time periods. We ran a few separate tests, iterating until the results were satisfactory. The goal was to achieve parity or near parity with the client-side tag. The customer's server-side event stream included both events from their native phone applications as well as their websites, so we were sure to filter that event stream to just website traffic for our testing. We also wanted to ensure that the events we were sending had all of the key information that the client-side tag provided. Our key metrics were event volume, match rate, which is how many of the events could be tied to an end user on Pinterest's side, and conversion attribution, just ensuring that conversions were being properly tracked and reported for the customer's partner connections. So with one event stream going straight to Pinterest via the client-side tag, and another going from the customer's servers to MetaRouter's platform, and then server-to-server to Pinterest, we ran a 2-day test over the last weekend in February. When looking at the data, we broke it out by event name and compared the volumes. As you can see here, some events are impacted more severely, but in every case, the server-to-server integration has a much higher volume. In most cases, it's more than double the volume of the client-side tag. Even conversion attribution increased in the server-side integration, which means that reports around the customer's partner connections are more meaningful and accurate when the data is being collected and delivered server-to-server. With the drastic difference in event volumes, it should come as no surprise that the volumes of events that were matched against Pinterest data were also quite high. Here, the server-side tag doesn't quite get up to the 200% mark that we saw in raw event volume, but these events on matched users represent user activity that could be quite powerful in behavior modeling. But it gets really interesting when we stop looking at raw event volumes and start looking at match rates. When you look at this data, it's really important to recall that the event volumes in the server-to-server test are nearly twice the volumes of the client-side tag. So we expect these server-to-server match rates to be a little lower than the client-side tag's match rates. What's interesting, though, is that they aren't low enough. The key takeaway here is that the server-to-server tag isn't just capturing more events from the same set of users as the client-side tag. We'd see match rates that are half of what we see here if that were the case. It's receiving events from more users. The client-side tag can miss entire sessions from users. Meanwhile, on the server side, we see a slightly lower match rate because, in many cases, we are sending events for users that Pinterest never would have even known had visited the customer site. It's really exciting.